This podcast is sponsored by AppDynamics. Software architects play a critical role in designing, executing, and migrating large infrastructures to the cloud. Download AppDynamics' free ebook, 10 Tips for Enterprise Cloud Migration, and launch your migration project with a proven plan. Download the ebook now at infoq.link/appdynamics.
Hello and welcome to another edition of the InfoQ podcast. My name is Wes Rice and I'm your host. The InfoQ podcast is produced by InfoQ.com. InfoQ is the source for senior software engineers, architects, and technical software leaders that covers industry news, advanced articles, timely podcasts, and through QCon, a set of international conferences that I chair, more advanced technical talks from people like Twitter, Google, Facebook, and many, many more on leading trends in software. QCon San Francisco is coming up this November, and it's going to be an incredible conference. The conference is featuring over 130 speakers. It's across 3 days, and will be 18 different tracks. A track is a vertical conference focused on a specific topic, like AI, machine learning, or functional languages, things like that. We have people like Tyler McMullen, the CTO of Fastly, that are coming. Mads Torgensen, the C# chief designer and spec lead. We have Lewis Ryan, who's one of the core developers of gRPC and Istio. We've got people like Tyler Akodo, who's going to be hosting a panel on SQL over Streams that will feature Jay Kreps and Michael Ambers from Databricks, Julian Hyde, the original developer of Apache Calcite, and Stephen Wynn, the CTO of Data Artisan, who makes Flink. There's luminaries like Adrian Cockcroft and Randy Schaub. It's going to be an incredible conference, so be sure to check us out. On today's podcast, I'm talking to Guy Podjarny. Guy is the co-founder and CEO of Synk. Synk helps companies use open source software while staying secure. Before Synk, he was a senior member of Akamai, where he was the CTO of the web experience business. He's got over a decade of experience in application and cybersecurity, including a stint with cybersecurity as part of the Israeli Defense Forces. Today on the podcast, we talk about things like the Equifax hack and the lessons that we can all learn from it. We discuss serverless and some of the common problems he sees that at Synk of application developers leveraging serverless. We discuss the anatomy of a serverless hack. What are the types of things that attackers look for in serverless platforms to be able to get in? Then we wrap up with security hygiene best practices that developers should follow in developing applications that leverage open source software and serverless. Guy has incredible insight into the space, and it was an awesome chance to really talk with a thought leader in the space of software security. Hope you enjoyed the podcast. It was awesome to record. Welcome to the InfoQ podcast.
Thanks for having me. Happy to be on it.
So tell us a bit about Synk, the work that you guys do.
Sure. So at Synk, we, at a high level, help companies use open source code and stay secure. So we try to sort of tackle this risk that exists, that's sort of a fundamental risk with using open source for sort of mission critical systems. At the end of the day, you're kind of downloading code off the internet, right? And running it typically blindly in your system. So this is sort of a high level concern that we have that we're sort of trying to help. So this is probably one kind of premise of what Synk does. And specifically today, we focus on vulnerable libraries, known vulnerabilities in open source libraries, Maven, NPM, RubyGems, and the likes. So try to curate known vulnerabilities in them. We've got a security research team in Israel doing that. And then using that database of known vulnerabilities, build tools that are very developer friendly, very much like things that fit into your existing continuous workflow and help flag those issues and, more importantly, fix them.
Are these like static code analysis? Is it dynamic code analysis? Yes.
No, so it's a very, very common question. And so the analysis that tries to flag known vulnerabilities in these libraries is all of the above. We have what we call the vulnerability pipeline that does a variety, it does some of its own analysis, static or dynamic. It does some listening to like the GitHub fire hose. So if somebody opens a GitHub issue that says SQL injection and it sort of disappears into the ether, then we try to flag those and get them to our analysts and curate them. And all of that eventually is just feeds that get into our security team and gets manually vetted. And at the end of the day, makes it into a database. That is the database we have. The tools that you use as kind of a user of Synk, they don't do static analysis. They don't look at your code at all. They only look at which dependencies you're using. So you're looking either in a built environment that like the files deployed, or when you integrate to like GitHub or GitLab or whatever, at the manifest files, which kind of get expanded to a tree and intersected with the database to say whether you're using vulnerabilities. And then we've got like these fix buttons that then in turn connect to like the ecosystems to say, fine, you're using this vulnerable library. You should know about it. Here's details about what that is. But then, if you click this button, then we would find the minimum upgrade necessary to kind of make that go away.
That's cool. So it's looking at the third parties that you're pulling into your system. So the boundaries of, I guess, your code and other code that you're pulling in.
Yeah, absolutely. And I guess my thesis here, sort of our thesis, is that, first of all, it's its own threat and you need to deal with it. Second is this threat is actually, these types of vulnerabilities are much easier for attackers to exploit. It's effectively the same problem that happens when you don't patch your servers, right? When you don't sort of apply those updates, or when you don't update your operating system, right? We all get these prompts to say, do you want to update now or do you want to do it later? It's like later. But you kind of know that you need to update. Otherwise, you have some vulnerabilities in there and you'll get compromised. So the same premise happens in applications, and we're just a little bit less conscious or a lot less conscious of it. So those are the types of vulnerabilities that are very much there, are easy for attackers to exploit because a single vulnerability has many, many victims. The vulnerability is already found, so it's very compelling. And on top of it all, more and more of our code, when you look at what makes up an application today, it is increasingly, more applications are more assembled than built, right? You build components, you build elements to it, but the vast, vast majority of code is becoming these third-party components. So basically, with all of those, my belief at today and even more tomorrow, the bigger security risk that you have in the application is from these vulnerable third-party libraries, not from your code.
Totally. Yeah, absolutely. It's the unknown vulnerabilities are in these third-party libraries. The static analysis and the other tools that I've used in the past were always analyzing my own code, which totally, I get it. There's certainly some things in there that I found using them. But more often there were false positives that were identified because something was named in a way that triggered a static analysis to pick it up. And I'm like, no, that's just a false positive, or I'm doing this to mitigate that. It's fine. But the third-party libraries were things that were never really analyzed or discovered to really let me know where my vulnerabilities were. So yeah, it makes total sense.
I might have built some of those tools that reported false positives for you because I worked on a tool called AppScan, was sort of the first black box testing, sort of DAST, dynamic application security testing tool earlier on, and then expanded to run AppScan Source, AppScan Developer Edition, then Source, which did static analysis. And it's a fascinating space, like I've done, I've got like a dozen patents in that space, and it's very much about trying to like mathematically, enumerate or model every possible path through your code. And it's just naturally false positive prone. And it's still good. I'm not, discouraging people from using static analysis, but it's just important to do that distinction that, in the world of identifying vulnerable libraries, it's interesting, like from a reporting perspective, there are zero false positives, right? As long as I could build up the tree and I've got the database that is accurate, it'll tell you. The one kind of catch to that is that a vulnerable component does not equal a vulnerable system. If you have, a vulnerable library, it doesn't necessarily mean you're using it in a way that your application would be compromised. But what it is it's, first of all, it might be. And second, it's a ticking time bomb that's sort of sitting there. Because even if you explored all the different paths to that code today, tomorrow, somebody would build another piece of code, or you will build another piece of code that would make it into it. So it's a lot of this sort of cadence. And I really feel like the analogy to patching your servers is an apt one. No pun intended, I guess, that, it's basically the same concept of sort of patching your dependencies and knowing what vulnerabilities in them and fixing them on a non basis that we're so familiar with in the world of infrastructure.
So you just mentioned a phrase, a ticking time bomb. That seems like a really nice transition into the next portion I wanted to talk a bit about. So I wanted to talk about the Equifax hack in particular, because this is kind of your space. It was open source software. This is one of the things that Synk does. So that was a remote command execution. Have they specifically specified what the actual vulnerability was?
Yeah, it was actually, it's not common that a breach of that magnitude really goes down to such a kind of clear-cut single source of attack. When this was initially released, there was just like these kind of small indicators that said it was some struts2 library vulnerability. But it was later clarified that this is a very trivially exploited remote command execution vulnerability in the struts2 library, which is a very popular Java library. And it really is quite easily exploited. There's a bunch of headers, including, I think, the content type. where you just need a certain format, a certain text. You can hack the curl and you run a remote command execution. I actually have, if you felt like it, you can go on GitHub to snyk/java-goof, and it's a demo Java application that is susceptible to it. And there's a little exploits folder. And you can see all you need to do is cat that file and just replace the word command with whatever command you want, and it would run on that server. The vulnerability is very severe. It's not unique. There are many others like it that get released regularly. This intersection of a very easily exploited vulnerability with a very a highly popular library is something that happens, a handful of times a year. And yeah, it caught Equifax. So I guess the timeline, as I understand it, I think it's been fairly confirmed, is that the vulnerability was disclosed in March. It caused a lot of noise. Everybody was kind of running around trying to find all the sort of applications they have. Equifax did learn about it, so they were aware of the vulnerability, but they didn't have apparently kind of good curation of which systems are using that library. So they missed the fact that at least this one, maybe other applications were using that vulnerability. So somewhere between 4 days after and 2 months after, there's a bunch of details there that's not formal. They got hacked, and they found out about it in late July, and they reported on it in September, which is a whole problem of its own.
It's unreal. I mean, just notwithstanding when they reported, just everything else, it's pretty dramatic. It's like a made-for-TV special for security or something.
It just it has all the thriller ingredients in here, right? It has the most precious data that you could have stolen, right? Data that you cannot change. It's not a card you can change. It's not, your sort of target shopping history. It's not whatever, some hidden, some movie from Sony or something that got leaked. It's your date of birth. It's your social security number. It's past addresses. It's all this historical information you can't change. It's really, really sensitive data. It's massive volume. It's like half of the US and with some sort of tendrils into the UK and Canada. And then Equifax really couldn't have botched it any worse. First, this vulnerability, which is actually, in all of the things they've wrong, that is the one that is maybe being in this world. There are many, many organizations that didn't properly patch this one. But then subsequently, if you compromised an application, you shouldn't be able to access 140 million records so easily. And if you did, that should be easily detected. And they just went on to just really handle poorly everything after, from standing up a phishing-like site for a phishing-looking site to ascertain whether or not you've been breached with this component, to blame on one person, so having the CEO testify to Congress and say that this happened because one person didn't do his job. So yeah, they couldn't have failed more spectacularly than they did here.
So that's a great bridge. I mean, this is your space. It's open source software in an enterprise that was a third-party library that exposed a company because of poor practices. What are some of the lessons from this hack that you'd recommend people pay attention to?
I think there are several of them. The most immediate one has to do with open source libraries. So it's just about an appreciation of it. If you had a really good system for patching your servers and doing that in a regular cadence, it wouldn't have saved you from this attack. You have to sort of understand that this type of threat exists in the application layer as well. And application libraries fall in this twilight zone between infrastructure and code. On one hand, they are perceived as a part of the application. On the other hand, they're libraries that you pulled in remotely, and it doesn't really matter if it's Struts2 or it's OpenSSL.
Yeah, and in Struts2's case, well, definitely in the case of OpenSSL too, these libraries could be really prolific across the enterprise. I mean, Struts2 isn't exactly the new hotness when it comes to front-end MVC frameworks. The odds are if you're still using Struts2 in your production app or with this app, it's likely in some form of maintenance mode.
People don't like upgrading, if there's no need. So probably first and foremost, and this is, as you said, kind of my space, is it serves as a wake-up call to say you need to pay attention.
Okay, so what do you recommend to help people not be the next Equifax?
One of the key components of it is, what are we doing about this types of vulnerable libraries? The second aspect of it is on how do you do it at scale? Like many people pointed fingers. I really don't like the blame game that exists in the security space. I'd like to be constructive. So actually, I had a post about this, and it was all about the fact that there was really no a single person or point. Frankly, this was before the CEO pointed the finger at one person. That it's not really one person's fault. It's a whole system. It seems trivial to say, why couldn't you have just upgraded that library? But reality is that it's really hard. Some of the things that are easy to do in a single unit are really hard to do at scale. So patching your application singular is easy. You need to assess it. Maybe there's some testing you need to do, but patching 1,000 of them, patching 10,000 of them, and doing that regularly and knowing which application is using which library and tracking that over time and across people that come and leave the company and contractors. And it gets hard. It gets hard very quickly. It's kind of like wrangling servers is hard. And that's why, platform as a service or serverless and all these came about. Wrangling applications and knowing what you have is not simple. So I would say lesson number 2 is don't just think about, a single action, but think about how do you build systems for it, right? Think about how do you architect a solution that naturally fits into the way you build software and allows you to keep track of what's being used, where, and sets you up to be able to respond quickly to these attacks. There was an interesting kind of anecdote that we didn't talk about, which is in Equifax, it took them forever to patch the system. But the attacks actually started happening very, very quickly. So there's a bunch of stats from Imperva and Alien Vault and other parties that track these types of things that show how really within hours of the disclosure of this remote command execution kind of happening, right? So the CVE coming out into the wild, they've seen, hundreds and thousands of attackers out there trying to exploit this vulnerability. So every time a new vulnerability disclosure happens, there's a race that kicks off. Who gets there faster? Does the attacker exploit it faster, or does the defender protect their systems faster?
Yeah, and the defender's always at the disadvantage, right?
Absolutely. The defender has to get it right every single time. The attacker is fine with statistical success. Coming back to scale, or to systems really, it's about not talking about how would you single case fix this, but rather talk about how would you put in place systems that allow you to, across all of your applications, tackle this type of concern, know who's using what, and be set up to fix these problems very, very quickly.
But I guess it's also worth commenting here that while Struts 2 is well known, everybody knows about it, it's been out there in the wild a while, these types of problems are not just a Java problem. It's not just a Struts library problem. You noted in that blog post you just mentioned a few minutes ago that, similar things with Node.pg and cross-site scripting in Python. You mentioned a lot of other ones that are out there. So we really have to be holistic in how we think about the systems and the libraries and all of our open source software.
Yeah, absolutely. So open source is everywhere, right? And it's amazing. It allows us to move fast as an industry, as a community, and everybody loves it. And we're just using and consuming more and more of it. And today, the notion of a package manager and libraries are a core element of any programming language. So Maven is actually one of the older platforms, maybe sort of package management systems. And even the stats around Maven usage are growing very much by leaps and bounds. NPM is the fastest growing, probably, package manager. And we're seeing, I think over 500,000 different packages there. And they're reaching some ridiculous numbers of daily and monthly downloads. So, but it's true also for Go and for Rust and for Elixir and every one of these systems. And it's not, we live a lot in the world of NPM and we talk about JavaScript, and people from other systems like to point the finger at NPM and says, this is ridiculous. Look at how many, they have a library that does 5 lines of code and it's downloaded 20 million times a month. You could argue a little bit around whether that's a good thing because it means, you just have this richness of functionality at your fingertips, or if it's a bad thing because of fragility. But the bottom line is it doesn't really matter what are the sizes of the libraries or how important they are. Our dependence on open source packages is true throughout the ecosystem. And all of them, looking at them and building a database on it, all of them repeatedly have severe security issues, from remote command execution, sort of heartbleed style information and memory disclosures, to all sorts of deserialization concerns that can just blow up servers, denial of service concerns, really kind of across pretty much all aspects of vulnerabilities. So you shouldn't pigeonhole this neither on Struts 2 nor on the NPM ecosystem. And it's also not really different ecosystems have technical differences that sometimes have security implications, but fundamentally vulnerabilities is a natural part of, it's a bug, right? So find me a language where developers don't bugs, that language might be resistant to this type of threat, but I don't think that exists.
How do you keep track of it all? I mean, with this, everything's so different. How in the world do people actually be able to track across all the different platforms and stacks and libraries that are out there?
The snarky answer is to use Sneak. We definitely do a lot of work in the space. I do think higher level is that you should use tools. This is not a core competency for pretty much any shop. And just like you rely on, Canonical or Red Hat to your Yum upgrade or apt-get, you should be using the appropriate tools for your environment to help you with that. I'm actually about to release a book with O'Reilly titled Securing Open Source Libraries that is supposed to come out in November or December. So there's a lot more detail about it over there. So definitely check it out when it comes out. But at a high level, you need tools to integrate into it. And those tools have to be integrated into your existing workflow. So if you build a tool that developers or the practitioners need to go out to another tool and remember to do it, or if you build a tool that is too strict and breaks builds whenever you have some problem and gives you no way out and is too cumbersome, they would hinder adoption. And at the end of the day, you're not actually going to successfully deal with this risk. So, first you need to find tools that support your stack. There are various tools there. There's the OSS dependency checker and RubySec and Node Security Project and tools like that are open source tools. They're nowhere near. All of them are not as good as the commercial tools in the space, but they are far better than doing nothing in the space. So you can use those. You can use commercial tools like Sneak that, just sort of support a broader set of ecosystems, have deeper databases, and just put more effort into kind of integrating with your workflow. But whatever tool you use, just make sure that the way that you can integrate it into your system is smooth. The other tip I would say, and it's something that in security is not as obvious as it should be, is you need to keep in mind that your goal is not to find issues, your goal is to fix issues. So when you design a system, when you think about how would you architect for this, when you choose a tool, don't look for the tool that would alert you to the issues fastest, or don't look for the model in which you will get the email. Because you're going to get a lot of emails and it's just going to create notification fatigue. And if you don't have clear-cut forward motion, say, how do you fix this? Then it's not going to work and the issues are not going to be fixed and you'll just have more, Jira tickets in your backlog. So just think about your strategy for fixing. And we talk about 4 phases, about find, fix, prevent, and respond. So find the issues, fix the issues, prevent additional vulnerable libraries from being added to your system, and then be set up for response to sort of win that race that we talked about before.
Awesome. I want to shift gears just a little bit into serverless. So at QCon San Francisco here in a few weeks, you're doing a talk that dives into serverless and specifically targets security. So we all know that serverless is kind of about, it's a cloud computing execution model where you're basically running functions or on someone else's resources and they manage it. What is the value proposition in your words for serverless? Let's start there.
First of all, I should say that I'm a big fan of serverless. I think it has a lot of good value propositions in it. First of all, the word is annoying, serverless, but it's kind of catchy. And I like the debate that it triggered. I think of it as server management-less. You don't need to manage servers. The server is very much still there, but you don't need to manage it. And that's great from the reducing load and all sorts of complexities from you. And it has a lot of goodness from a security perspective. But I think the value proposition for serverless is really around lower cost of ownership. It's the fact that you can just run it, and that lower cost manifests in less people time, in less machine time, in lower operating costs. Literally, it's just a much more cost-effective way to run a system.
So earlier when we were talking about some of the vulnerabilities with open source software, you said something like people don't like to patch their servers. So if that's a really super common security vulnerability, people just not patching things, updating libraries, serverless is the panacea, right? I mean, Amazon or whomever is going to make sure that you're always patched, you're always up to date with what's there. So this is a more secure environment, right?
It's definitely an environment that reshuffles security. So it shuffles security priorities. So to start off, yes, there are a lot of great improvements from a security perspective that serverless just natively offers. And chief amongst them is the fact that you don't need to patch your servers. And patching your servers, as we mentioned before, is hard, and it's hard to do at scale. And now you're sort of leaving it to the pros, leaving it to the platform to run it for you. And that's a great thing. And there's all sorts of stats, but basically the vast majority of successful exploits today happen because of known vulnerabilities in dependencies. So being able to worry less about that. You still need to trust your platform operator to do it, but worrying less about it is a big deal, and it indeed helps security. It also takes away other security concerns or this reduces them, like a persistent compromised server. So when you think about how attacks happen today, they don't really happen in one go. They happen in multiple phases, maybe except for the Equifax example, but typically Target and Sony and the Panama Papers and all of those examples show how it was done in stages. So in serverless, because there's no stateful system, so it takes it away. So there's a lot of goodness. There's a lot to celebrate in the sort of security improvements that serverless brings forward.
Yeah, that was kind of a setup. There's a but coming, right?
But attackers are not going to give up. It's right there. And if we move our applications there, and if our applications are sufficiently valuable, then they would just shift their priorities and they would focus on other areas that are still there. So I've given a lot of thought and some talks on this. I would say, if I'm to narrow it down, one key area of security that serverless highlights is application security. So because you don't deal with infrastructure as much, all of the application security concerns, from the SQL injection in your code to authentication concerns to vulnerable libraries, vulnerable application libraries, all of those just become more relevant in the space because they would be the next or the easiest paths of attack for an attacker. So that's sort of one attribute where it's not that serverless is worse. It just means if you're in a serverless environment, put your security efforts on that, right? On sort of this aspect of application security, whatever sort of shift some of the effort you would have put into infrastructure security and securing your servers.
You actually said something in one of the talks that I watched prepping for the podcast, was something about that it's a kind of a different way of thinking. You need to actually think of functions or each of the serverless functions as kind of the perimeter. That is the perimeter of your application. Can you expand on that a bit?
Yes, and I think that's the area where serverless increases security concerns. So what serverless does more is it creates more flexibility, and with that, it creates more attack surface. So now you have a bunch of these functions, and serverless gets you to this place in which there's really no reason not to deploy a function. It's effectively free. You're deploying it. You're paying like whatever for the zip storage on S3. It's really, really a minuscule amount. So you're just deploying functions by the bucket load, and each of these functions at the end of the day is an opportunity for an attacker to come in. So the very same flexibility, when you think about the fact that serverless allows you to build these functions and just assemble them in whatever way you want, each potential additional path in, each additional interface, each additional permutation is another opportunity for a break. It's another opportunity for unintended consequences to allow to run through. So first of all, serverless just increases the complexity of the attack surface. And by doing so, it does increase the risk. It increases the paths for attackers to come in. The other thing it does is, we think in functions or we think about assembly, but in reality, if you look at practice, I talk to a lot of organizations that started using serverless in earnest, and they still think about their applications as a set of these functions. And what happens is that they would put security controls in the early functions that are supposed to be exposed, and then they would reduce or remove those security controls later on. This might be around input sanitization. It might be around permission or authorization to say who's allowed to do it. So you get this combination of effects or of behaviors where you have a lot of functions, and each of those functions is another piece of functionality that might be broken, and they might be assembled in different ways. Many of these functions rely on other functions to be ahead of them, but that's not encoded in any mechanism or anything like that. Somebody could just as well create a different path for it. And there's this natural implicit trust that's created between the functions, right? They just assume that they'll be okay because they're on the same network or the same system. And that's a very, very fragile system. It allows different paths for an attacker to come in, but it's also one of those, it's like the M&M security model, right? You're sort of relying on a hard shell, but it's all soft and gooey on the inside. As soon as you get in, you can now kind of roam not quite free, but you can roam to these other functions and you can cause a lot of damage. So to break that up, serverless, the good thing about it is that all of these systems give you the controls to think about every function as its own little independent autonomous unit, and therefore secure it, right? Put some control who can access it, put controls about what it's allowed to do. So if compromised, it would minimize the damage it can cause. That, put some controls around, maybe even like with the API gateway or such, some schema enforcements around what inputs are allowed to do. So there's a lot of goodness in the platforms that you need to take advantage of. To just think of every one of these functions as its own perimeter for you to create a system that's a little bit more resilient over time. Some of it is in just good use of like IAM models and permission models in these platforms. And some of it is in the code to create things like, good shared input validation libraries that you're going to use across your functions. But just, build models that make every function be, a bit of a fort onto itself. And it's hard to do it at scale. So to me, if I think about security concerns, what concerns me the most about serverless is that we find ourselves in 3-4 years' time with organizations having thousands of these functions. They have very, very light controls. They have permissive models. I like to say that, permission models or access models, these policies never contract. They only expand, right? They expand until somebody puts an asterisk, right? And then it's done, and it's really hard to claw back permissions. So that's my primary fear around security in the ecosystem, is that we're going to trade hard to wrangle servers with hard to wrangle functions if we don't plan ahead for it.
How do you even manage that holistic practice of updating security policies? For example, if you have 10 or 20, that's great. If you get hundreds or thousands of these and you discover an issue with some security permission across all of them, how is that even practical to be able to go through there and even know that you've created this one-off S3 security policy? How do you manage that?
I think taking a page of the whole DevOps, core manifestos, which is it's about automation and it's about visibility. So you need to measure everything. You need to know, be able to track how many buckets get created and how many of these files and how many functions, and just have them all listed somewhere. And then you need automation. You need to automatically inspect them, but also sometimes automatically generate a bunch of capabilities. So iRobot actually does some really cool stuff around their IAM user role management, and they auto-generate them based on a set of configurations on the side as a part of their deployment model. So I like that, right? If you can keep enforcing that component, you can do things like disallow deploying multiple functions within the same serverless framework YAML. So that forces you, if that's just not allowed, you have to define them for every single function, because one of the common mistakes is that you just have 10 functions just for convenience, throw them all into one manifest, and then they all share the maximum permissions across all of them versus the minimum permissions. I'm a systems person, right? It comes back to trying to mechanize these controls into your system. So the one good thing that you do have is that the frameworks themselves in these functions, in these serverless environments, function as a service, the functions are managed by a relatively small number of platforms, right? You're probably just using Lambda or maybe Cloud Functions or maybe some OpenWhisk system. So you can use the APIs of those platforms to enumerate all of your functions and test them. And building tools that rely on those interfaces are helpful. I did that a fair bit with Synk. It's kind of still a slightly newer area for us, but it so far is proving quite good, which is we can connect to the Lambda system, use the API to discover all the functions, and then use the API to download the zips, expand them out, see which libraries are in them, and flag the ones that are vulnerable. And then do that in a recurring fashion. And the good thing is, because of the APIs and because of the sort of centralized access to the list, you can actually do it in a very easy to use flow. Just run it on all of them.
What about multi-cloud environments? Do you have any insight into tools that maybe allow you to target GCP, target AWS, target Azure for Azure Cloud Functions? Are there tooling out there? Has the maturity of the ecosystem come up to where I can work in a multi-cloud environment, still be able to auto-generate these policies, for example? Is anything out there that exists like that?
So not really. I mean, I think the serverless framework is probably the most sort of ubiquitous kind of open source tool that would support all these different ecosystems. In general, tooling in the serverless space is very, very nascent. There's no, Lambda is king in this space. The other systems are very interesting and they're growing fast and they're getting a lot of investment. But there is no doubt that the vast, vast majority of users are in Lambda. So any serverless tool that comes out there, first and foremost, cares about building a solution for Lambda. So you need tools to get to the second level of maturity to go and expand beyond the dominant player. But the space is so new that very few tools have reached the second level of maturity.
So stay tuned. They're coming, I imagine.
Exactly. I do think that there's a certain amount of concepts that apply across these systems. So if you're a Google Cloud Functions user and you see a vendor that has a Lambda tool out there, odds are that you can talk to them. As soon as they get a critical mass of Cloud Functions users, then they would build their support for it. Many of these tools are not quite as tightly tied to one ecosystem as the other. They just need to accumulate enough critical mass of customers or users to justify the investment.
So I want to ask you another question, because I've seen you do some talks that live do this, and they're super impressive. And you're going to do this at QCon San Francisco, so I'm looking forward to it as well. But can you kind of go through anatomy of a hack when it comes to serverless? I mean, these are stateless functions that spin up and are gone. How does an attacker go about thinking about reasoning about a hack with the serverless?
Fundamentally, hacks happen in stages. So there's this, movie scene pictures that we have in our minds that we think that, somebody just goes in and all the way through kind of breaks in. Typically, that's not what happens.
Well, unless it's Equifax, right?
Maybe unless it's Equifax. Yeah, you need to open up a more sort of spectacular hole to allow for that. When you look at attackers, there are two classes of attackers, very, very simplistically put. There are statistical attackers, automated scripts that run around and try to find a victim, and they don't really care about who the victim is. That's sort of a secondary thought. And then there are targeted attacks. There's notorious like advanced persistent threat type notion that they have a specific target in mind. Sometimes it's media companies because it's the Syrian Electronic Army. Sometimes it's financial institutions because it's financially motivated kind of organized crime. Sometimes it's politically motivated, like nation states and maybe critical infrastructure that's being targeted. So, you have both those classes. Most people listening here, most people in the world are not heavy targets of the second class. They are targets of the first class. They have automated tools out there that constantly run and try to compromise them. So for those types of solutions, they work on patterns. So what would happen is, for those tools, they would be attacking many, many systems. They would discover systems around. They would use a series of exploits. Sometimes it's some automated heuristics, automated logic to try and break in. Basically not that unlike automation we build in the defender side of the fence. And then once they manage to get in, then they would try to just advance the next step. So they would try to, install some agent or get some hook in, and then start exploiting kind of what happens after. This is sometimes referred to as the post-exploit phase, which is you've already found a vulnerability, you've exploited it, so you got in, and then you're applying it. And then you proceed and you go deeper and deeper into the network. So sometimes you're trying to search for data. So you're going to try and, if maybe you got in through some remote command execution vulnerability or an SQL injection vulnerability or something like that in an existing system. Then your next step is going to be kind of exploring what you've got. What do I have around? And you're trying to do all of that while evading detection. So you try to do it at a certain pace. You try to do it, you as an attacker, right? You try to do it without breaking yet, right? You want to be there.
On a serverless environment, though, it's stateless. So how do you work in stages on a serverless environment?
Yeah, so first of all, it's not entirely stateless. The server is still around. So you get in, and the containers in practically all of these systems, but notably, as we said, the Gorilla is in Lambda, functions are effectively containers that get spun up and they get run, and they don't get disposed on every execution because that's very inefficient from a latency and cost perspective. So containers remain up, oftentimes referred to as they remain warm. These systems, you call the function and you call that function again. So if you just made a stream of small single calls to the same function in Lambda again and again, you could see, if you looked at the logs or if you looked at your application, that it's actually running on the same instance again and again. So first of all, it means that if I exploited, and I have this in some talks, including the one in the upcoming QCon, is that if you exploit this vulnerability, if you have a remote command execution on a function, you can actually now modify the files that are deployed on that container so that any future victim that comes along would be compromised now and be affected. So you can trick them, you can get the data that they send. So this is a remote command execution, and if you manage to get something persistent, it is more short-lived, so you're in better shape than if that server lived for a while, but it is still very much not single use. The other aspect is that even if it was a perfect scenario and this server was entirely stateless and got discarded after every time, once you're in and you've got the remote command execution, now you are deeper into the network. So you will explore, can I access some databases? Can I access some other functions? Can I do something? And eventually there are persistent entities out there. You can poison data, you can steal data, or you can just siphon off data from one-off requests, or maybe get to a non-serverless system behind. So I do think serverless improves your security posture, but it doesn't mean that it just takes it out of the way. It doesn't mean that this is not a concern. It mitigates some of this concern. At the same time, you need to now monitor for suspicious behavior, 10 times, 100 times more functions. Once again, something you have to do at scale, and it's easy to say that for one entity. Actually, I don't know, it's not that easy to say it even for one entity, but it is especially hard to do it for many, many of them.
Let's start to wrap this up. You use the term security hygiene quite a bit. What are some security hygiene tips that people should be aware of for serverless and just in open source security in general?
So security hygiene is, in my mind, the most important aspect of security for any organization to try and cope with. And maybe I would add to that, security hygiene at scale is the most important aspect. So it's a lot of fun to talk about the fancy attacks, about the indeed advanced persistent threat, and around nation states and the like. But as I mentioned, the statistical attacker is the one that is probably targeting you the most. And when you do that, then oftentimes all you need to do is you need to be better than the next guy, right? You need to be able to defeat those automated attackers so that it is more expensive, there's more effort to break into your systems. So to achieve that, you need to do some of the basics for security at scale across your system. So in the world of open source security, that implies first and foremost patching. If you're still running your servers, you need to make sure that they are up to date, because those are the vulnerabilities that are most prevalent and easiest to exploit. In the application side, you need to ensure that you are aware of vulnerable libraries in your system and you need to fix them. And then on both of those, you need to do that at scale across all of your applications. Alongside that, if you talk about cloud security or broader, you can start talking about permissions and access. We just saw Accenture leak a whole bunch of information because they didn't properly configure access permissions on a bunch of their S3 buckets. Configuring access permissions for a single S3 bucket is very, very easy. Configuring S3 bucket permissions for 10,000 or 100,000 such buckets is not. So it all comes back to being able to do the basics at scale very well, which I think is a lesson that hopefully most operations people can relate to, because it's the same challenge that you have at scale. It's not about the fancy, super disastrous, hurricane that hit your data center. That's not the thing that would make you crash most of the time. Most of the time is just a lot of small resilience entities that you didn't put in place. And then the third bit that I would consider under security hygiene is this notion of defense in depth, which is don't assume that a sequence of events or that a single layer of protection is infallible. Just understand that everything is fragile and that your world is dynamic of all these systems. So when you talk about applying security basics at scale, think of them in the resolution of a unit that is the smallest unit that you can possibly cope with, right? It might be the function, it might be a container, it might be a server, and that core concept applies beyond just the systems that you're running. It also talks about an individual on your team who has access to it. Can you minimize permissions to a developer on your team? Do they really need to be able to see all of your customers' data? Is it okay if they don't have it? It comes back to your dev environment. Do you really need your staging environment to have a full production database replica, including all the data, which just increases the risk, or can you deal with less? So if you deal with security hygiene at scale well, you have solved, in my opinion, 99% of your risk. There might still be some, cyber arm of some army that would target you and they would break in. But to deal with that, you've got to be in a whole different league.
So if you want to learn more about Guy and the work that he's doing at Synk, check out his book that's coming out, you said later towards the end of the year, on open source security. Is that what it was?
Indeed, it's called Securing Open Source Libraries by O'Reilly, and I hope we'll be giving it up for free around sort of late November.
Make sure to check out that. You can also check out many of his talks that he's got online. You'll have one at QCon San Francisco that's coming up here in November. And also check out Synk.io to learn more about the products and services that Synk does. Well, Guy, thank you so much for taking the time to chat with us.
Thanks for having me.
At the beginning of this podcast, I mentioned the upcoming QCon San Francisco. If you missed that one and are listening to this a little bit too late, QCon AI is a brand new software conference we're also running in the Valley, but this time it'll be on April 10th. QCon AI is a software conference for software engineers who want to bring more machine learning and artificial intelligence into their teams. This is a different take on AI conferences. This is not an AI conference targeting data scientists. This is an AI ML conference for the SWE. It's for you on how you can use ML and AI in your own shops. Check out QCon.ai to learn more and see if this approach resonates with you, as it has with literally every developer I've talked about it. Software is changing the world, and ML and AI is eating software. This is definitely a space that I want to grow my own personal career, and you should check us out. Whether it's this November or in April 2018, I hope to see you at an upcoming QCon. QCons are an awesome experience. Thanks again for listening.